Good day, folks. This is an electrodynamics question. It's a September 2024. It's a Northwest question paper. All right, let's cut the chase. It says a simplified diagram of an electric machine. It's not specified whether it's a generator or it's a motor. But looking at this, there's no power supply here. That means it is a generator. If there's no power supply, a battery or a cell, that means that's a generator, right? And we're given the magnets north to south and the coil there and the slip rings, and this is an external circuit. Now it says, is an electric machine a generator or an electric motor? So it is a generator. One of the reason that you can say here, no power supply. There's no power supply there. Or you can state the energy conversion, or you can say it is the energy conversion is from mechanical to electrical, right? Okay, now let's go to the next question. The next question, it says write down the name of the component ABCD. So the component that is labeled ABCD here, it's the what? It's a coil. The name of that, it's a coil, or it's an immature, or you can say it's a conductor. Right, let's pass that. Give reason why the carbon is preferred over iron for the brushes in the electric machine. Why these are the carbon instead of iron there? Because they're a good conductor of electricity. The carbon is a good conductor of electricity. Right? In which direction is the current flowing? A to B or B to C? First we have to look at guys, it's really difficult to show this. If you're looking at the coil there, the coil is moving clockwise. So if it's moving clockwise, that means the ABC side, that means they're asking from A to B or B to C. That means the focus of the coil is going to be this side, right? So if the coil is moving clockwise there, that means the ABC side force is going what? Upwards, right? And then the direction of the magnetic field is going in that direction. So that's B for magnetic field, the F for force there. So now looking at those two, they must be perpendicular to each other. That means if you're using the right hand rule, guys, you're pointing your pointing finger from north to south. You are pointing it to south using your right hand rule, and then your force using your thumb is going to be up, and then you can see that your middle finger, it is going to point towards B. That means your current, it's going to be in that direction. This will be your finger. This is going to be your pointing finger, and then this will be your thumb, and then that will be your middle finger, which is the current. So the current direction there, it's going to be what? A to B, right? And then in 9.5 it says the graph below of voltage versus time was obtained from alternating current. If you're looking at this graph, this is the graph of alternating current of the generator, and this is the graph of the what? The potential difference, or the EMF, that is induced versus time. So do you see, this is one complete wave, and what we're given here, it's time, which is, this is the period. This is going to be what? T. That's the period. So if from here to here it's 0.0.1, that means from here to here it's another 0.0.1. It's going to be 0.02, right? This is one cycle. So from here it's a half a cycle, and this is a full cycle. It's a half wave, and this is a full wave, which is a one wave, right? Now in 9.5.1 it says calculate the frequency. 9.5.1 calculated the frequency. The formula for the frequency, it says frequency is equal to 1 over t. This 1 means one wave over time. So when do you get the one wave? You get the one wave over what period? A 0.02 period, right? In a 0.02 period, so you'll say 0.02, that's a one wave, right? It's one in a period of 0.2, so it's going to be what? 50 hertz. So the period of that, it's 50 hertz, right? Alternatively, you can say frequency is equal to frequency of this wave. In a half a wave, you can put 0.5 there, and then you divide by what is the period there? It's 0.01. It's going to be what? 50 what? Hertz. Basically, you use the formula that says frequency is equal to number of waves divide by total time. So it's the number of waves. It's one wave. Do you see one wave? The period, it's what? It's 50. The period is this, and then it give you the frequency that is 50 hertz. And then here in the number of waves, you put the what? The half a wave, half of the wave here. It's half there, and then the period, it's 0.01. It gives you 50 hertz, right? Let's go to 9.5.1. It says calculated the average power. We want power there if the generator produces the maximum current. So in 9.5.2, guys, here in the graph it gives us the Vmax there, which is it's 250 what volts, and then it gives us the maximum current, which is the Imax, which is it's 2 amperes there. So now having that, we are looking for the power average. The power average, we're getting it first from the formula that says power average is equal to, that's the easiest, IRMS times VRMS, right? So but in our, what we're given, we're given the maxes. So that means we must convert these maxes to what? To IRMS, and this one to VRMS using the formulas that we're given on the data in the data sheet. We'll say VRMS is equal to Vmax divided by square root 2, which is the Vmax, it's 250, we divide by square root 2. When you punch that in the calculator, it gives you 176.78 volts, right? And then when we change the Imax to IRMS, it's Imax is equal to, no, sorry, it's going to be IRMS is equal to Imax divided by square root 2 is equal to, the Imax is 2 divided by square root 2, it's going to be 1,41 amperes there. So we've changed that, so we can finally use the formula that says P average is equal to VRMS times IRMS, right? So it's going to be 176.78 times 1,41, and then your answer there, it's going to be 249.26 watts. That's the power. Alternatively, if you don't want to convert those RMSs, you can use this formula, but this formula, P average, is equal to half P max, and half P max is equal to, the P max is equal to V max times I max, and then it's going to be half your V max there you were given, it's 250, and then your I max you were given, it's 2, right? So your answer is going to be 250 watts on the dot. It will be accepted, but you must be mindful, this formula, it's not in the data sheet, right? or in the formula sheet. So you should use what you are used to. There's so many ways to do this, guys. There's so many ways. I hope that makes sense, guys. Cheers. Bye.